In the second example, I have a bag containing 4 red balls. Oops, that's not red. Let's say 4 red. 1, 2, 3, 4. And 3 green. 1, 2, 3. So I have 7 balls overall, and a ball is taken out at random and then put back. This part here is quite important, as you'll see in some future videos. But then I take a second ball, and it's asking for the probabilities that both of them are the same colour. So I could have the probability of it being red and red. And this is the key word. Because I'm saying "and" here, I have to multiply the two probabilities together. So the first probability of taking a red is not 1/7, it's 4/7. And the probability of taking out the second one is also 4/7. And the reason it's the same is because I have put back the first ball. And I multiply these together to get 16 out of 49. But that's being the same colour, not to say that they're both red. I could also have the probability of them being green and green. And that would be 3/7 multiplied by 3/7, which is 9 out of 49. And because now I could have two different possibilities, I could have this, I could choose a red and a red, or I could choose a green and a green. The word there I used was "or." And because I could have the first line or the second line, the "or" refers to adding. And I have to add these two probabilities together. Because they both have the same denominator, it's still going to be out of 49. But the number on the top will be 16 plus 9, which is 25. So the answer to part A is 25 out of 49. Now, I'm going to clear some space here to do part B. At least one of the balls is green. So let's do that in a different colour. I'll say at least one of them is green will be a green and a red, or a red and a green, or a green and a green. And there are 3 different possibilities I could choose. But here's the sneaky trick. There are only 4 possibilities. The other one, which I haven't listed, is red and red. And rather than working out all of these and adding them together, it's much easier to do all of the probabilities which add up to 1, and then taking away the red red. And the red red I've worked out here. 16 out of 49. And by subtracting these, I will find the probability of all of the first 3. And that's quite a nice trick. 1 is the same as 49 out of 49. So 49 minus 16 is 33. I would have got this 33 out of 49 if I'd have worked out each one of these and added them together. But it is simpler to do this. So the answer to part B is 33 out of 49. The answer to part C, to say that the balls are different colours, that is to say, it could be a green and red, or red and green. Now, I haven't worked out what these probabilities are, but I have worked out what these two are, which is actually the 2 probabilities I'm not considering. And I'm going to use the same trick. I will do all the probabilities and minus these 2, which I know are these 2. So that's 16 out of 49 and 9 out of 49. And if I took both of them away, then this would give me 24 out of 49. Remember, I would have also got 24 out of 49 by looking at these two probabilities and adding them together, but I think there's a bit more work to do there, because I've already, in the previous parts of the question, I've already worked out what these are, so I'll use that instead. So this is 24 out of 49.